Welcome to the third and final outcome. This is where it all comes together, writing and submitting a well-structured research report on your chosen computing topic. The final task is to write and submit a properly structured report on a named computing topic. It draws together everything so far: a quality question, ethically collected data, an accurate analysis, all in your own individual, referenced work. A clear structure is what lets a reader follow your argument all the way from question to conclusion. And it's worth remembering, the marks come from structure, evidence, and referencing, not simply from the topic you picked. Start by choosing a focused topic you can realistically research in the time you've got. Narrow it into a clear question, something like, does a solid-state drive noticeably speed up application launch times on an older laptop? And check you can gather the data ethically and reach any tools or people you need. A tight scope beats a broad one every time. Real depth on a small question scores better than a thin skim across a huge area. Benchmarking hardware, a usability survey, testing an algorithm, or evaluating an AI tool all make good, focused projects. A report follows a standard shape that examiners expect to see. It moves from the title and abstract, through the introduction and literature review, into the method and results, and then closes with the discussion, conclusion, references, and appendices. Each of those 10 sections has a clear job and links naturally to the next. Following this map is honestly the simplest way to make a report count as suitably structured. The title page carries the essentials: the project title, your name, the date, and the word count, and the title itself should describe the study, something like a benchmark comparison of boot times across 3 operating systems. The abstract is a short summary of the whole project, usually around 150 to 250 words, capturing the aim, method, main result, and conclusion in miniature. A useful tip: write the abstract last, once you actually know what you found. The introduction sets the scene and explains why the topic matters. It states your aim, the research question, and the objectives, defines the scope, what you are and aren't covering, and briefly outlines how the rest of the report is organized. Think of it as answering 3 simple things: what am I studying, why does it matter, and how will I go about it? The literature review summarizes what others have already found on your topic, drawing on reputable sources, textbooks, peer-reviewed journals, and official documentation. The key thing is that it's not just a list of summaries. You compare sources and point out the gap your own project fills, and every source is cited in the text and listed in the references. For a benchmarking project, that might mean reviewing published SSD versus HDD results before running your own. Done well, it shows you understand the field and exactly where your work fits. There's a nice way to picture a report's shape: an hourglass. It starts broad, narrows to your specific study, then broadens out again. So the introduction and literature review move from the general topic down to your question. The methodology and results are the narrow, focused middle, and the discussion and conclusion widen back out to what it all means. Keeping that shape in mind stops a report feeling like a set of disconnected sections. It's one of the simplest tricks for making your writing flow. The methodology explains how you collected and analyzed your data, and importantly, why. It states the method, whether a survey, interview, or benchmark, along with the sample and the procedure, and it records the controls you used, which is exactly where reliability lives. It also notes the ethical steps, consent, anonymity, and secure data storage. The real test is simple. A reader should be able to reproduce your whole study from this section alone. The results section presents what you found, clearly and without interpreting it yet. Use labeled tables and charts for quantitative data and themes for qualitative data, and report your figures accurately, including the sample size and any spread, such as the standard deviation. Keep the raw data tucked away in an appendix and show the summarized results here. The discipline is to describe the data now and save what it means for the discussion. The discussion is where you explain what your results actually mean for the research question. You link your findings back to the literature. Do they agree or disagree with what others found? You acknowledge limitations honestly: a small sample, a single machine, one time period, and you stay careful about causation. Using is associated with unless your design truly proves cause. This is the section where you show independent thinking, not just reporting. The conclusion answers your research question directly and briefly. It sums up the main findings without introducing any new data, restates the key limitations, and suggests what a follow-up study could look at next. So you might write, on this hardware, the Linux distribution booted fastest. Further work could test a wider range of machines. Short, clear, and honest is exactly what you're after. Let's see this structure fleshed out with a worked outline. A student testing whether quicksort outperforms bubble sort on large datasets. The introduction sets the aim of comparing sorting speed and asks which is faster as the data grows. The literature review brings in the known big O results. Order n log n for quicksort against order n squared for bubble sort. The methodology fixes the same language and machine with data sets from 10,000 up to 1,000,000 records and 20 timed runs each, and the results show, in a table and line chart, quicksort pulling far ahead at scale. The discussion notes the results match theory, flags the single language and machine as a limitation, and suggests testing merge sort next. Here's a quick reminder of what a few key sections do. The abstract is a short summary of the whole project: aim, method, result, and conclusion. The literature review is a critical summary of what others have found, with citations. The methodology explains how and why you collected and analyzed the data in enough detail to repeat, and the appendices hold your supporting material: the questionnaire, raw data, code, and consent form. Each has its own distinct job. Harvard referencing has two halves that always work together: in-text citations and a full reference list. A book reference gives the author, year, title in italics, edition, place, and publisher, while in the text you cite briefly something like Dawson, 2015, or Dawson, 2015, argues that. The rule is that every in-text citation must have a matching full entry in the list, and vice versa. And consistency matters. Pick one Harvard style and follow it throughout. In practice, an in-text citation is just the author, surname, and year, like Oates, 2006. And if you're quoting directly, you add a page number too. The reference list is arranged alphabetically by author surname, not numbered, and you reference everything you cite: books, journals, websites, datasets, and any reused code. Tools like Cite Them Right Online show you the exact format for each source type. Accurate, consistent referencing is a core part of a suitably structured report. Different source types follow slightly different patterns, and it's worth having them to hand. A book runs author, year, title, edition, then place, and publisher. A journal adds the article title in quotes, the journal name, volume and issue, and the page range. A website gives the author or organization, year, title, then available at the URL with the date you accessed it, and a dataset follows the same idea but flags it as a dataset. Keep these templates nearby, and referencing becomes almost mechanical. A few habits keep your writing suitably academic. Write formally and in a neutral voice, third person rather than slang or text speak, and be precise. Define your technical terms and then use them consistently. Guide the reader with clear paragraphs, headings, and numbered sections, and support every claim with evidence and citations rather than opinion alone. And do proofread for spelling, grammar, and consistent formatting before you submit. It genuinely affects how your work reads. It's clarifying to compare a strong report with a weak one. A strong report has a clear question and a matching structure, a method others could repeat. Data shown in labeled tables and charts, findings that are interpreted with limitations stated, and full, consistent Harvard references. A weak one drifts, a vague topic with no real question, a method too thin to reproduce. Raw data dumped without explanation, claims with no evidence, and referencing that's missing or inconsistent. Knowing the difference tells you exactly what to aim for. Before you submit, it's worth running a quick quality checklist. Are all the required sections present and in order? And is your aim and research question clearly stated? Are your findings backed by data in tables and charts? And have you addressed consent, anonymity, and GDPR? Then check that every source is cited and in the list, and that you've proofread, met the word count, and got the title page right. A few minutes on this catches the easy marks people so often lose. The whole journey runs through 5 stages. You plan by choosing the topic, question, and method, and agreeing the scope with your tutor. You gather data ethically and record it clearly, and you analyze by summarizing and interpreting it accurately. Then you write, drafting the report section by section using the standard structure, and finally, you check and submit, proofreading and completing your referencing before the deadline. Working through them in order keeps a big task manageable. Here's a complete example. A student researching how usable a new campus timetable app is. The introduction sets the aim of assessing usability and asks whether students can find their timetable quickly and easily. The methodology has 30 students complete a set task, then a 5-question survey with responses anonymized as P1 through P30. The results give a mean ease rating of 3.8 out of 5, with 60% finding their timetable in under 10 seconds, and the open comments coded for themes. The discussion concludes, usability is reasonable, but navigation friction keeps recurring. Limited to one campus and app version, and every source is listed in Harvard style. When it comes to submission, hand in the final report by the deadline in whatever format your tutor asks for. Include all the sections, the reference list, and any appendices, your questionnaire, raw data, and consent form, and keep a backup. Checking the file opens correctly before you send it. Do remember to reference any UK Versity slides you've used, for example, carrying out a research project 2026. A complete, well-referenced, on-time submission is exactly what this outcome asks for. Let's draw the final outcome together. The project is an individual, well-referenced report on a focused, named computing topic, and a suitably structured report follows a standard order: title, abstract, introduction, literature review, methodology, results, discussion, conclusion, references, and appendices. Each section has a clear job, and the report moves from broad context to a focused study and back out to wider meaning. Harvard referencing ties your in-text citations to a full alphabetical list covering books, journals, websites, datasets, and reused code. In the end, quality comes from clear structure, evidence-based findings, honest interpretation, and accurate referencing, submitted on time. And that completes the unit. For putting a full report together, Dawson's Projects in Computing and IT and Cottrell's Study Skills Handbook are both really practical companions, and Oates is excellent on the research process as a whole. When it comes to referencing, Cite Them Right Online is the tool to keep open, and the BCS Code of Conduct is a good reminder of your professional responsibilities. You'll find the ebooks and journals for this unit on Moodle, so lean on them as you draft, and the very best of luck with your own research project.